For the system of equations above, what is the value of x plus y? So I have to solve for both variables and then add them together. I'm going to solve the second equation for x by subtracting 2y from both sides. So x is equal to 4 minus 2y. Then I can plug that in here. The next step is to distribute the 2, then combine like terms. And it turns out that y is equal to 0. If I pick one of my original equations and plug into 0, it turns out that x is equal to 4. So 4 plus 0 is 4. What is the solution xy to the given system of equations? So each of the answer choices has the x answer and then the y answer written like this. Makes a lot of sense to me to just use substitution. Y is equal to 3 plus 3, or y is equal to 6. So given those two facts, our answer is A, because they already tell us what x is equal to. Which of the following ordered pairs x, y satisfies the system of equations above? So for each of these, the x answer is first and the y answer is second. I could double this entire top equation. This is what I get. Then I can use elimination and add straight down. And the y's go away. And this tells me that x is equal to 2. If I plug that back into one of my original equations, like x plus y is equal to 0, I now have 2 plus y is equal to 0, which tells me that y is equal to negative 2. B. Which ordered pair xy satisfies the system of equations above? If I wanted to get rid of all the fractions, I could multiply everything on the bottom by 8 and everything on the top by 4. This is what I get. I could use substitution or elimination here. Let's say that I added y to both sides. So I now know that x is equal to 152 plus y. And I can take this and substitute it in for x in the other equation. This is what I get, and I have to distribute the 2. And I can combine like terms and solve for y. If I look at the answer choices, do any of them have y is equal to negative 264? This is the only one. I could just stop there and be done. Which ordered pair xy satisfies the system of equations shown above? If you wanted to get rid of the fractions, you could take the second equation and multiply the whole thing by 2. You're left with this, which is a lot easier, I think, to deal with. We're going to take what x is equal to, plug it in over here for x. This is my new equation. When I combine the y's, I have this. If I move the 3 over, and if I divide, are there any other answers with y is 3 other than B? Nope. Which ordered pair satisfies the system of equations shown below? If I double this entire top equation, I end up with 4x minus 2y is equal to 12. Now I can use elimination to add straight down. So I have 5x is equal to 10, or x is equal to 2. If I pick the second equation there, I can say that 2 plus 2y is equal to negative 2. And if I subtract 2 from both sides, I have 2y is equal to negative 4. So y is equal to negative 2. And you'll see that you have to be careful between B and C. Make sure that you pick the correct order of positive and negative. If xy is a solution to the system of equations above, what is the value of x minus y? So find both, subtract one from the other. So to use elimination, I'm going to have to multiply the top by, let's say, 3 and the bottom by 2. If I want to use elimination, I can subtract all 3 columns straight down. If I do so, the x's go away. And remember, because I'm subtracting, this is minus 6x, this is plus 4y, and this is plus 12, effectively. So I'm left with negative 5y is equal to a negative 30. And if I divide, I get that y is equal to 6. Let's plug that back into one of the original equations. If I multiply and then move the 12 over, I get that x is 2. So 2 minus 6 is equal to negative 4. C. If xy is a solution to the system of equations above, what is the value of xy? So find the answers and multiply them together. I'm probably going to use substitution. Since they tell me that y is equal to this, I can substitute it into the other equation. So 2x, whatever that is, squared is 64. If I take the square root of both sides, I get that 2x is equal to 8, or x is equal to 4. If I take this original equation, negative 3 times 4 equal to y, negative 12 is equal to y. So negative 12 times 4 is negative 48. If xy is a solution to the system of equations above and x is bigger than 0, what's the value of x and y multiplied together? So if I use substitution and replace y with what it's equal to, x squared, I have 2x squared plus 6 is equal to 2 times x plus 3. Or 2x squared plus 6 is equal to 2x plus 6. If I subtract 6 from both sides and move the 2x over, I get this. Or 2x times x minus 1 is equal to 0. So there's two possible answers. Either I can plug in 0 here, or I can plug in 1 here. Both of those will make that true. In other words, x is 1. So if I go back to one of my original equations and I say y is equal to 1 squared, well, y is also just going to be 1. So 1 times 1 is a. The graph of a line in the xy plane has slope 2 and contains the point 1, 8. The graph of a second line passes through the points 1, 2, and 2, 1. If the two lines intersect at the point AB, what's the value of a plus b put together? So I'm going to start with y equals mx plus b and looking at line number 1. I'm going to put in the points 8 and the slope 2 and the point 1, and this will help me figure out my b value. 8 is equal to 2 plus b, so b is equal to 6. So my first equation, y is equal to 2x plus 6. Then I'm going to use the change in slope formula, y2 minus y1 over x2 minus x1, to find the slope of the second line. And it turns out it's negative 1. Then I'll pick one of my points, plug in a 1 for the y, a 2 for the x, a negative 1 for the m, and this will help me figure out b. So 1 is equal to negative 2 plus b. So b is going to equal 3. So my second equation, negative x plus 3. So I can set these two equal to each other. 2x plus 6 is equal to negative x plus 3. If I move the x to the left and the 6 to the right, I get that x is equal to negative 1. If I plug that in to one of these equations, I'll pick the top one. Y is equal to negative 2 plus 6, or y is equal to 4. So if I add these two together, 4 plus a negative 1, the answer is 3.